that are naturally smart are terrible at learning.
So we're really gonna fail this now, and I just
How many questions were there?
I don't know. 11.
It is time.
11 or less.
It is not time, so I'm gonna fail.
It's not a quiz. It's a review. We're reviewing.
I'm still gonna fail tomorrow.
Oh my god.
No, I'm actually gonna stand.
Where's the Luke? Can you bring that over here, please? I would prefer not to get on. Thank you. I seem to not like that.
All right, we're live. Let's do this.
Ellie, what did you do to it?
All right, so proof number one. A lot of these diagrams, huh?
You want us to turn these in from yesterday?
Nope. That's for your own health. If you want to turn it in, go ahead. I guess. I mean, we can make it self-development, perhaps.
Yes.
Okay, fair enough.
What's self-development?
It was for your own health. Yesterday, what I did with first hour before I realized I had to be gone for third and fourth, I apologize for that. Initially, I thought I didn't have any meetings. I was like, yes, everybody else has them. I don't have any. Turns out I ended up having two, twice as many as normal. So I missed third hour and fourth hour. What we did in first hour, though, is we said spot the stuff, basically, where I gave you a diagram and I said, if I tell you these two are congruent, what does that mean? Well, then those two angles have to be congruent, and so on and so forth, right? We just did really quick proofs without writing it down. It was really beneficial for them, so I want to make sure you got a similar thing, so that's why I gave you that stuff. But anyway, let's get down to business to defeat the Huns. AC and BC are congruent. So that means this, right off the bat, if I put that down, what does that tell you? Isosceles triangle, so we can use the isosceles triangle theorem, and those two angles will be congruent, right? We're not going to write that down yet. D is the midpoint of AE, okay? So here's AE. D is the midpoint means this. And if E is the midpoint of BD, well, if that's half, this must be the other half, right? So it turns out all three of these are congruent. We're going to prove that CD and CE are the same thing. So these two lines, right? Now, what do those lines belong to? They belong to this triangle and that triangle. So if we prove these two triangles congruent, then we win. Alternatively, we could get these two angles the same, and then we win, right? That would also work. So I'm going to prove the triangle's congruent. That's just what I'm going to do. I'm going to get more information as much as I possibly can. I already mentioned some earlier. What more can we add to the diagram? Zayden, go.
Those two angles with using the isosceles triangle.
Awesome. So let's be specific. CAD is congruent to CBE by isosceles triangle theorem, right? We have an isosceles triangle because this and this are the same. So by isosceles triangle theorem, we know that AC, oops, sorry, that's already given to us, angle CAD, CAD, is congruent to angle CBE. So, boop, boop. We got that. Now what? What do you see? What do you see? What do you see? What do you see? Someone other than Zayden. Only because I want to make sure everybody gets a chance to try and look for things. What do you see? SAS, side, angle, side. Side, angle, side between the two triangles so we can prove that they are congruent. So we're going to say by side, angle, side. Does everybody see the side, angle, side? Side, angle, side. The two triangles are congruent. I'm going to call that triangle ACD. Congruent to the other triangle. A matches up with B. C matches up with itself. And D matches up with E. So BCE. Again, you can check the sides to make sure those angles are congruent. So now we've got this. We want to prove CD and CE congruent. Well, luckily, CD and CE are part of these triangles, right? So we can say by CCD. And we're done. Remember, CCP is corresponding congruent parts. It means if the triangles are congruent, then their parts are congruent, right? The corresponding parts. Notice CD and CE are corresponding. They're in the second and third spot, right? 2 and 3 for both. So they are congruent. We have to be able to say the triangles are congruent first before we can use CCP. But after we've got that, we get the parts. How you feel? Yeah, Danny.
Can I bring a chair up there?
Yeah, it's fine. How do you feel? Decent? What if I said, just kidding, I don't want you to prove that, I want you to prove those two angles are the same? What would be the last step you'd have to do?
Side, side, side.
You did the isosceles triangle.
Isosceles triangle theorem, right? We have two congruent sides, so two congruent angles, we're done, right? Oh. Red, red, red. Let's go to do number 2. Yeah, it's gonna be all right, right?
Yeah.
Okay.
Alex can put 5 up here.
All right. So they give you triangle ABC, and they say that AD and BF are congruent. So let's mark that. AD and BF are these segments right here. CD and CF are also congruent. CD is this, CF is that. All right, all right, all right. We also know that DE and AC are perpendicular. So here's DE and here's AC. Perpendicular means it hits 90, right? So these are both 90 degrees. Same thing here. We got 90s, which means HL is on the table, boys. We're going to prove that E is the midpoint of AB. So here's AB, here's E. In order for E to be the midpoint, we know that these two segments have to be congruent, right? So if we can get these two to be the same, then by definition, E is the midpoint, right? Now those two segments belong to these two triangles. So if we can prove these two triangles the same, then we get these two segments. And then by definition, E is the midpoint. What do you see that we can add to our diagram? What more do you see? What more do you see? Zayden, get us started.
You should do SAP to get the two long sides CB and CA be the same.
Exactly. So these two sides are congruent. Here's how he knows it. This side is equal to red side plus blue side, right? And this side is equal to red plus blue. So if that's red plus blue and that's red plus blue, they must be the same, right? So by segment addition postulate, right, we said the two small pieces add up to the big one. We know that AC is congruent to BC. Pretty cool with that? Right. Yeah, this side's made up of blue and red, this side's made up of blue and red, so it must be the same, right? Okay, so now we've got that.
That's just doing 2 segments.
Two segments can add up to a bigger segment.
Yeah.
We also use that when we have the whole thing in one piece, and we can say, like, if we had this in the red, then we could, and we had this in the red over here, then we could say these are the same. Right, exactly, right. Black minus red equals blue, black minus red equals blue, so they must be the same. Yeah, what do you see, Coda?
We already have that given, so why are we?
We aren't. We're given that AD and BF are the same, those two bits. Remember when I make those little tick marks, it only applies between here and here, right? So Coda, that mark right there only applies between here and here. And then this mark only applies between here and here. So we weren't given the whole side was congruent to the whole side. Nowhere does it say AC and BC up here. But through logic, we know that these two sides must be the same because red and blue makes the whole side, and red and blue makes the whole side over here. Are you looking at 2?
I'm looking at 3, that's why.
You're looking at 3. Ah, all
I
right.
like the same one.
Yep, similar diagrams, different things are marked. All right, so we've got this. What else do you see?
Shared side.
What do you mean shared side? Remember, shared side is when we have something like this. Two triangles that share a side. See how both those triangles, the left side and the right side triangle, share that middle side? I don't see any shared sides here.
Can we make like a...
Vertical angles is when we have this, right? And X and top and bottom are the same. I don't see any X's.
Can you draw a line from D to F?
This right here is not vertical.
D to F though, if you draw a line
That's a little bit.
and then you make it
Well, that makes sense. B to F.
D to F.
D to F and draw a line. You can do that if you wanted to. I'm going to refrain from that though, just because that's going to make things more complicated. You can do it without. But sometimes you need to, yeah. Zayden, what do you see?
Isosceles triangle theorem.
Guys, the whole thing's an isosceles triangle now, right? So by the theorem, these angles are the same.
I'll say
Don't forget to look at the big picture. Angle DAE congruent to angle FBE.
How do you write isosceles triangle?
Isosceles triangle is the symbol, right? That's the symbol for an isosceles triangle, and then THN is short for theorem. The theorem says if you have two sides congruent, then you get the two opposite angles congruent. What do you see, Ellie?
How do you know if it's the converse or just the...
Great question. So this one, we already had the sides, and we got the angles, right? So the theorem is when you have this, you get this, right? The converse is the reverse of that. So it's when you have this, you get this. So when you already have the angles, then you can get the sides, right? It goes both ways. So if you have two angles, you get two sides. That's the converse. If you have two sides, you get two angles. That's the theorem. Yeah.
When you do side angle angle.
Check it out. We can't do side angle angle for these two triangles because we can do angle side angle though.
I was looking at the congruent F and B, and then the angle on B, and then skip the side.
Oh, side angle angle. All right. So the reason this isn't side angle angle is because to get from this angle to that angle, we have to skip a side, an angle, and a side to get there. Remember, you're allowed to skip one thing at most. Okay. See how these are all right next to each other? Angle, side, angle.
I put the vertical line. The left vertical line to the.
Oh, you put the line here.
Oh no, I didn't do.
What did you do? A line here?
A line straight down,
Like here.
like C to E.
C to E. Oh, here to here.
Yeah.
Okay, you could have done that, and then we'd have shared side, and then we have angle, side, side, but that's ass, which wouldn't work. Actually, no, HL would work. So we could prove
Yeah.
these two triangles congruent, and those parts would match up. Yeah, you could do something like that, but it's going to be more work. We've already got angle, side, angle here, so these two triangles are congruent, okay?
So then my CCP.
Angle, side, angle says the two triangles are congruent, so ADE congruent to angle BFE. I'm sorry, not angle, triangles.
Then my CCP.
Yep, then by CCP, we can say that this is the same and this is the same. So by CCP, we can say AE is congruent to BE. Remember, CCP means that if the triangles are congruent, which we just got done saying, right, then their parts should match up, right? There should be congruent parts. Well, which parts? The ones that are corresponding. AE and BE are corresponding because if you look, A and E are in the first and third, and so is B and E, right? So we're allowed to say that. Now, if those two are congruent, which we just showed they were, by definition, E is the midpoint, right? So let's write that. Then by definition, E is the midpoint of my line.
We can't see.
Yep. So by definition, E is the midpoint of AB. And we win. That's what I thought.
Go ahead.
How are you feeling about that one? I'll walk back, okay? Segment addition postulate says that blue and red makes up this side, right? And this side's also blue and red, right, combined. So those must be equal. We good with that? Landry, feeling okay with that? Then if those two sides are the same, then those two angles are the same by the theorem, right? Isosceles Triangle theorem. Now that we have those angles, right, we can say angle, side, angle. The triangles are congruent. So this triangle is congruent to this triangle. And if the triangles are congruent, then their parts are. So this part and that part are going to be the same. How do I know it's those two that go together and not like those two or something? It's because AE and BE are in the first and third spot together, right? So they're corresponding. So those are corresponding parts. So by CCP, they're together. Okay? Since that is true, I know that E is the midpoint, right? Because it cuts it in half. So by definition, E is a midpoint. Feeling better? Evan, do I have you up to here? Yep. What about here? Yes? Here? All right, so we found it. So the triangles are congruent by angle, side, angle. You're good with that? Okay? So when the triangles are congruent, we know that if they're the same triangle, then their parts should be the same, right? There should be sides that match up. There should be angles that match up, right? All of the parts should match up. That's what congruent means, right? There's an angle on each that matches, an angle on each that matches, another set of angle that matches, right? We have sets of sides that match. So here's what I'm saying. CCP says, Evan, you with me? CCP says corresponding parts are congruent, okay? Corresponding means same relative location. So if you look, A and E are in the first and third spot, right? Well, what's also first and third? B and E. So I should be allowed to say they're congruent, so I do. Notice that A, E, and B, E are these two, right? So I was able to say this using CCP. CCP says if the triangles are congruent, then their parts are congruent. Which parts? The parts that are corresponding in the same relative location. First and third, first and third. Evan, are you with me? I feel like you're zoning out while I'm talking. Yes, you are? No, you're not. Are you better now? Yes or no? Wonderful. All right, and then from here to here. If those two are congruent, then E is a midpoint, right? Because it cuts AB in half. Evan, you with me? Here and here? Excellent. Better? Red. How do you feel? Alex, you with me?
Yeah.
Got it. If you're not, it's okay. Let me know. We're not going to get through all these today, guys. I want to make sure we do what we do well. Landry? Feel okay? Chloe? Okay, red. All right, let's look at 3. All right, similar diagram. We're going to mark different things, though, so it's going to make it a different problem. Notice all these diagrams are from the packet we've been doing. I just marked different things. So they're going to create a different proof. All right, so they give you the triangle, and they say AC and BC are the same thing. All right, as soon as I mark this, what should be going through your head? Isosceles triangle, which means we're going to have angles, right, by the theorem, right? So we'll get there in a second. Don't do that yet. Make sure you mark the given first. That way you don't start just writing stuff down and don't give any reason for it, right? So mark the given. DE and EF are the same. So we've got that and that. So that's rad. AEF and BED are the same. So check it out. AEF is this angle. AEF, right? And then BED is this angle right here. And they're the same. So that's why I use the same color. We have overlapping angles. So what do you think we're going to end up using?
Angle addition.
Angle addition postulate, right? So the logic here is that this angle is orange, right? If I cut out this middle part, what's left over will be equal to orange minus green, right? Orange minus green gets me that. Do we all agree? Okay, look over here. Orange minus the green part gets me this. So both of these angles are equal to orange minus green. If they're both equal to orange minus green, then don't they equal each other? Yeah. So this angle and this angle will be the same. And that's by angle addition postulate. So by angle addition postulate, angle AED is congruent to angle BEF. Let me walk you through that again. Orange minus green gets us this angle. Orange minus green gets us this angle. Well, if orange minus green gets us both angles, then they're the same angle, right? Yeah.
Well then, since we have the isosceles triangle theorem,
Yep.
then D and A are congruent.
Yeah. So by isosceles triangle theorem, nice job. These two sides are the same, right? Which means these two opposite angles are the same.
Then you can do side angle.
Yeah, buddy. So we got angle A congruent to angle B. I can call it angle A and angle B because look, there's only one angle A, one angle B. Could I call this angle right here angle E? No, because we got 3 options, right? That's why we got to use the 3-letter name for it. But A and B, right? It's good. Only one angle A, only one angle B. Yeah?
Can I have an eraser, please?
An eraser? Yes. Here you go. Nice catch. So now we know that, and then Andre's right. We've got angle, angle, side here. Right? Angle, angle, side. We couldn't have used the orange angle before because that orange angle isn't part of this triangle, right? It's bigger. It goes outside it. But now that we have the pink angle, we're good. So angle, angle, side for both triangles. So I'm going to say that now. By angle, angle, side, those two triangles are congruent.
And then by CCP.
ADE congruent to angle triangle BEF. Again, write the triangle symbol so I know you're talking about the triangle and not the angles, right?
Wait.
So these two triangles are congruent. We wanted to prove AE and BE the same, right? So by CCP, the parts of the triangle should be congruent. So if they are congruent, then they should be by CCP. So we're going to go by CCP. AE is congruent to BE.
You did the AAS triangles wrong, I think. Okay,
Did I do? Nope. AAS. Or you could do SAA.
no, I'm saying, like, you did ABE and then you did,
Oh, I did. Good call. It should be BFE. Rad. Nice call, buddy. All right, AE and BE. Let's check those. AE, first and third. BE, first and third. Yeah, if I had screwed up my lettering there, I wouldn't have been able to use CCP, right? Good call, Andre. So I'm allowed to say that, so I do. And now I'm done. Very similar to the last
Are you gonna
problem
do
we
one of
did.
these by yourself?
What I would do is I would ask for like a blank copy, and I can give you a blank, and then you can go home and try it on your own.
Why is
Four.
it 8?
I don't know, first hour. ADEB is a line. That's what that means. So all of that is a straight line. Okay.
So that's
AE and BD. So yeah, your eyes are not deceiving you. Is all I'm saying. AE and BD are congruent. So let's mark that. AE is this, and BD is this. We have overlapping segments. So what do you think we're going to end up using?
SAP.
SAP, segment addition postulate, right? We'll cut out the middle and say the sides are the same, right? CD and CE are congruent, so that's these two segments here and here. And then they also give us that angle ACE and BCE are the same. So ACE is this angle right here, ACE, right? And then BCE is the mirror of that. All right, so we got overlapping angles too, so what are we going to use? Angle addition postulate, right? So let's do that first by angle addition postulate. I know that angle ACD is congruent to angle BCE. E is an elephant. Now, how do I know that? Here's the logic, guys. This green angle right here minus this black angle should get us the leftover, right? The green angle here minus the black angle should get us the leftover. So those leftovers are both equal to green minus black, right? If they're both equal to green minus black, then they're equal to each other.
well then can you just do by CCP right there?
So this angle and this angle are the same. We could have said the two big triangles like here and here are congruent, right? But we don't have enough information to say that these guys are.
Okay.
Right.
Well, and D and E or CDE you can do isosceles triangle.
Let me get there in a second.
Okay.
All right, so we've got those two angles. So by, oops, I already wrote them. So these angles are congruent, right? Sorry, I didn't use pink. Those two angles are congruent. Now we've got an angle aside and then nothing else, right? Because that blue part applies to this big triangle right there. So we don't have enough to prove these two triangles congruent, which should be our goal since we want these two sides. Actually, there's a much quicker way to do this proof, and I'll show you in a second. But angle side, we need some more information. What can we do to get more information? Go ahead, Coda.
Isosceles triangle theorem.
Isosceles triangle theorem is when we have two sides and we get the angle. So what two sides do we have congruent? Here and here? Okay. So we have DC and CE congruent. So that means these angles must be congruent. So by isosceles triangle theorem.
Wait, can you just skip straight to segment addition, or do you have
You
to
could have done segment addition as well. There's lots of ways to do this one, and I'll show you the really quick way of doing it. All right, so this theorem says those two angles are the same. So I'm going to say angle CDE congruent to angle CEB. And why does that help us? Go ahead, Zayden.
It'll let you use LPT to get angles CEB and angles CDA.
Yep, CEB and CDA are congruent by linear pair theorem, right? We know that the two angles here and here must add up to 180, right? So 180 minus red gets us this angle, right? Isn't this angle also equal to 180 minus the red? So then they must be congruent. Does that make sense, Ellie? Okay, so look here. Those two angles add up to 180, right? So 180 minus the red should get me this angle. Over here, this angle and this angle I don't know yet, right? Is also going to be 180 minus red gets me this. So if both of those angles are equal to 180 minus red, then they equal each other. LPT is when they're specifically equal to 180. Angle addition postulate is when they just equal another angle that we already know is congruent, right? So this is by LPT. Angle ADC is congruent to angle BEC. Now we've got enough information to prove them congruent. We've got angle, side, angle. We didn't even need to use the bottom part.
So by CCP.
So angle, side, angle, the triangle's congruent, and then by CCP, we get AC and BC, right? Let's get some more information though, just for the heck of it. What would we do with the bottom part if we wanted to get some information out of that? Zayden, give it to me.
Use SAP to get AD and BE.
So those two are going to be the same. And the reason for that, follow me now, is that blue minus this middle part, right, minus DE, gets me that, right? Well, blue minus DE also gets me this. So then they must be the same by SAP. So we can say that by SAP. I'm not going to write that down, right? We've got lots of options here. Now, let me show you something crazy. At the beginning, we had this diagram. We were given that AE and BD were the same. And we were given that these sides were the same. And we were given that these angles were the same. Do you guys see the big triangle right here? So we have an angle, green angle. We've got a side, and then we have another side. We've got ASS, right? Which isn't enough to get it done, but it's pretty close, right? So after we figured out that, what am I saying here? That these angles must be the same, right? We did that by Isosceles Triangle Theorem, right? Then we had angle, angle, blue side. And we could have called it a day just there. So if you see the big picture, sometimes you can get it a lot faster. But you guys did fine. We found lots of information, right? We're going to say the triangles are congruent, therefore their sides are congruent by CCP, and we win. I'm not going to write it. Do we feel okay moving on to the next one? Do we feel like we know what's going on? Is that a no? By LPT, those angles are the same. So by angle, side, angle, triangles are the same. Then by CCP, the sides are the same. Okay, let's look at 5. Buckle up. Don't be afraid of parallel lines. I hope after today you guys will feel more comfortable. It says FCG is a line, and ABE are a line, and they're parallel. That's what that means. So FCG is this line right here. So I'm going to put a parallel symbol in. Same thing here. So those lines are parallel. If we have parallel lines, we should be looking for CAP, right? Corresponding angles. Right? It says AC, this line right here, is bisecting BCG. Well, let's find where BCG is. BCG is this big angle. Does everybody see BCG? So that angle is being cut in half by AC. That's what bisect means, which means this angle and this angle are the same. BCG is this angle, and it's being cut in half. Feeling good? That's what I got from here. D is the midpoint of AC. So if D is the midpoint, that means it cuts this in half, right? D is a midpoint. We need to prove that BD, this segment right here, bisects angle ABC. That's this big angle. So the way to do that is to prove that this angle and this angle are the same, right? Because that means it cuts it in half. So we need to prove this angle and this angle the same. Those angles belong to these two triangles. So if I prove those triangles the same, then by CCP I get the angles, right?
Yeah.
Well, right now I have two matching sides for the triangles, and then I've got a single angle with no pair over here. So I don't have a lot of information to be able to prove them congruent yet. So I need to get more. They do have a shared side. So by shared side, those two triangles share a side. They share side BD. So BD congruent to itself. Right? They both use BD is what we're saying there, right? So now we've got two sides. We've got angle side side up here, which is AS. So we still need a lot more information. We don't even have the other angle down here for that, right? What more can we do? Nope, we don't know any right angles, so we can't use HL, right? What if we extended this line? Always extend your parallels, guys. Let's extend that into something. We'll extend that into point L for Landry. So how we do that is we say, let there be line LABE. Right? That's all we're doing. Let there be LABE, the segment, right? So we have two parallels. We have a line that cuts them right here, so that's a transversal. This is also transversal. I'm going to extend this transversal because that's the one that has both my angles in it, right? This one only has one of them. So I'm going to extend this. I need some letters for that. Let's see, let's do Z and Y. So I'm going to say let there be that, and let there be ZADCY. That's it. Now check it out. Here's what I've got. I've got two parallels cut by a transversal, and I know that angle, right? You guys see that? So that means I get this angle. That's this guy down here. So by cap, I know angle DCG is congruent to angle LAZ. I'll pause for station identification there. Do you guys see this diagram up here, how those two are corresponding? Right, bottom left corner, right? Here's our parallel, here's the line that cuts it, transversal. See how that's the bottom left corner of this intersection? And that's the bottom left corner? So they are corresponding. This angle and this angle. It's the same as this up here. You guys see it?
I feel like I'm not going to see that on the test though.
Right?
Then could you do by LPT?
Not yet. We're going to do vertical angles to get this, right? Because that angle doesn't even have anything to do with our triangles, right? But by vertical angles, right, now we've got an angle inside our triangle. So by vertical angle theorem, I know that angle LAZ from before is congruent to my new angle DAB. You could also do VAD if you want. Doesn't matter. Dab or bad, both acceptable. All right, we've got ass. Hey, when that happens. What other information can we get? I want to pause to make sure everybody sees this. Does everybody see the cap? Chloe, are you with me on corresponding angles there? Okay. What do you see, David?
Did you do Isosceles Triangle? Or is that used in Converse?
Converse, because we got two angles, baby. Woo! Right there. That's a big isosceles triangle, isn't it? Two angles, so we get two sides. Yeah, well done. By isosceles triangle theorem converse, right? It's the converse, Ellie, because we had the angles and it got us the sides, right? So that means AB is congruent to CB. Yeah. And now the triangles are congruent, right? We can use side, 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 or side, angle, side. What do we want, right? So by side, 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 the triangles are congruent. Then by CCP, these angles are congruent. So I'll write that out. By side, 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 triangle ABD is congruent to triangle CBD. Guys, we did it. We got them, boys.
I didn't
We
think
did it.
side, side, side was enough to prove.
We did it. It's the weed letters.
CBD? JH.
This is true. We did it, boys. We did it.
What's the
Do
sign?
we even have to do all that? Because couldn't you just said it as soon as those two matched?
The triangles are congruent.
Right, but couldn't you have just said it as soon as DA and DC were congruent? That it had to be?
No, because we had ASS. We had to get these guys.
Why do the triangles have to be congruent if those sides already are?
Because we want to prove these angles congruent.
Oh, I never
All right, so lastly, these angles are congruent by CCP, right? This angle here and that angle there. That angle is ABD. So if I look, ABD is first, second, third down here, right? So it should be congruent to first, second, third here. So I'm going to say by CCP, angle ABD congruent to angle CBD. Is that angle CBD up here? Oh yeah, it is. So by definition, BD bisects ABC, right? It bisects the two equal parts. again, what is a bisector? It's something that cuts it into 2 equal parts. Did we prove that it was 2 equal parts? Yeah, we did. So by definition, that's a bisector, right? How do you feel about that when we back up and go over it again? Yes? All right. By shared side, we get these guys, right? This guy's congruent to itself. We good with that? Then we said, let there be these lines, so we extended them. When we did that, it became more obvious that these two are corresponding, right? And then we said by vertical, those are the same. Then we said, if those two angles are the same, then by the isosceles triangle theorem converse, those two sides are the same. And now we've got side angle side, or side side side. We did side side side, right? Saying this triangle and this triangle is the same. And if those triangles are the same, then their parts are A, B, D is in first, second, third position. That's this angle right here, right? First, second, third position is also CBD, which is this angle. So those two angles must be congruent by CCP. And if those two angles are congruent, then yeah, it does bisect it, doesn't it? So by definition, it does. How do you feel? Feel okay? All right. 6. Here we go. CA and CB are the same. As soon as I mark this, Landry, what's going through your head as soon as I mark that? It's an isosceles triangle, so we're going to use isosceles triangle theorem. So we're going to get those two angles. Don't do it yet. We want to make sure we get our givens first, and then we back up our stuff. FAB and FBA, FAB and FABA, are congruent. So we get this angle and this angle. As soon as I do that, what should be going through your head? Isosceles triangle theorem converse, right? We're going to get those two sides. Okay? We're proving two triangles congruent. Which triangles? These triangles, just so you're aware. This triangle and this triangle is what we're trying to prove congruent, okay? All right, tell me what you see. Go ahead, David.
Vertical angles.
Ooh, vertical angles. Yep, we've got some right here and here. So by VAT, angle DFA is congruent to angle EFB. What else you got, Andre?
By SAT, wouldn't BA and EB congruent?
Say it again.
By SAP, BA and EB congruent?
Nope, because we don't know how they're divided up. Great point, though. So see how we know the whole thing, right?
Yeah.
But we don't know where D and E are, right? D and E could be anywhere in between A and C and B and C, right? If we knew that these were the same, then we could say, oh, pink minus that gets us this. Pink minus the same thing gets us that. So they're the same. But we don't know. We only know one of the three parts, so we can't do it. We know the whole thing, but nothing about either part here, right? So can't do SAP. What do you see, David?
So for the isosceles triangle, are you going to draw the angles?
Wow, rude. Are you going to do that, or
Couldn't you do, no, you don't do this.
angle DAB? Don't you dare. Angle EBA.
And then with the two smaller angles, you do.
The two sides, the converse, yeah.
And then you do angle side angle for the two
Whoa,
triangles.
calm down, calm down. Getting all excited over here, freaking nerd. By the converse, we get the sides. So AF, haha, yeah, boys, BF. Aww. BF is AF. I said as twice, that's funny. All right. Does everybody see how we got all that?
How did you get the angle and the...
Which angles? The blue angles?
Those two.
I got the vertical.
So now we've got angle and a side for this
I'm
triangle.
talking about the angle inside the...
This guy right here?
EBF triangle.
EBF. Oh, EBF. This angle right here.
Yeah, so would it be linear or vertical?
These two are vertical.
Okay.
That's the X, right? So those are vertical. Guys, all we have is angle and a side right now. We need to get some more information. What more information can we get about these triangles? This pink angle does not apply to that triangle, so we can't do angle side angle yet.
Oh, okay.
This thing again.
What? Angle addition, right? Pink minus blue gets me this. Guys, make sure you're seeing this. Pink minus blue gets me that, right? Well, over here, isn't pink minus blue going to get me that too? So that means these two angles are congruent by angle addition postulate. So by angle addition postulate, we're very pastel right here, very Easter colors right now. By angle addition postulate, DAF, that angle, is going to be congruent to EBF. Now we got angle side angle, and if we've got angle side angle, the triangles are congruent, right? Evan, I know that's you, without even looking up. He's just... I went to school for that. Drumming? I know. Ready for 7? Here we go. Let's skip it. We've done it before. Boo. Ready for 8? Here we go. They say ABD is a straight line, so that's good. No tricks there. BC and DE are parallel, so mark it with a parallel symbol. Guys, watch first hour's review because they got 3 more questions, okay? C and E are congruent. That means this, right? B is the midpoint of AD.
Did we skip 7?
Oh yeah, we did. All right, so here we go. We got parallel lines. We should be looking for corresponding angles, right?
For the C and E, just right a line.
It's a little curve, right? Because the angles are congruent. Yeah. All right, so those angles go together. Again, I'm using color, so make sure you do like double bands or triple bands for your angles, right? You know what I mean by that? Right? If you're doing it in black and white and you want to mark these angles congruent, make sure you put 2 bands there instead of 1, right? Okay, cool. Same thing with your tick marks, right? Yeah.
I forgot which thing it is, but wouldn't you be able to say that AB and DB are congruent because
That was given to us.
yeah, no.
This is the midpoint. Yep.
Yeah, the midpoint. So you can say that.
Yep. So we got that. Yep. All right. So I'm going to extend my parallels. That's always a good idea. Let's extend them into L and H for Landry Harmon, and then Z and P for Zayden. Well, all right.
Don't
So
say
that was definitely on accident, but we're going to keep it.
I didn't know what I was talking about. So,
All right, and then what's our transversal that's cutting these two? Well, we've got these guys, right? That's true, but I think more interestingly is this transversal. So let's extend that out. Let's do Y and X.
wait. I'm still trying to get the other stuff.
Yeah, dicks. So check it out. I'm going to turn this sideways. Do you see
Wow.
that this angle and this angle have to be the same?
That really makes it simpler.
2 parallels cut by a transversal, bottom left corner. You see it?
Yeah.
That's cap.
No, that's not cap.
That's cap.
Straight fact. There's cap.
If I draw it like this, I think you'd agree that these have to be the same, right?
So then you can do side angle.
Okay? If you need to, draw the stuff you're interested in and see if it's cap, okay?
Then you do side angle.
So by cap,
Geometry.
angle CBA congruent to angle EDB. And then by angle side, triangles are congruent. Not so bad once you see it. Looks angle side.
Please come to the office when the bell rings.
Triangle ABC, DE.
Paul Johnson, Toby Troutman, and Aaron Wolf.
You go too fast.
Thank you. Watch first hour's review. They did more problems. Okay? Check them out. I would encourage you to get a blank copy from me at some point. I can give you it now, and you can try it against the stuff you've already written down. I'll go grab some copies right now.
Never mind. Oh wait.
That was like the short spell ever.
I have art next, so I'm gonna get a book copy.
Why is UX? Hey, you're gonna forget your phone. Oh my god.
I understand.
It's on my seat.
I'm like one seat.
Alright, I got blank copies if you want them.
See, there's no way I'm gonna remember the angle things on.
Andrew did best. There you go. Anybody else want a blank copy?
Nah, only those
Yes.
stuff.
Oh, that reminds me, Zayden, guess what? Gotcha.
You haven't gotten that one yet?
No, saving it for you, bud.
Oh, of course.
Saving it for you.
I got Mark yesterday with one of them.
You just got. It's two. Two down, baby.
It's alright. I already got one too. Get some more.
Damn, what is up? So me and Mark taught the class yesterday.
Yeah, I heard about that.
You didn't do that.
Hello, Miss Sandra. I like your hair.
And honestly, I don't know how it went myself. All I know is I stabbed myself in the eye with my own glasses.
Cheyenne said something about cake.
Oh, yeah. Is she supposed to give you guys cake? Oh, yeah. Wait, Cheyenne was third hour.
Cheyenne told me that I get a piece of cake and I'm the only one.
Well,
I'm just,
if
I
Cheyenne's
don't need
saying it, then the cake is
I don't need a piece of cake though.
I need to turn this into an actual fridge.
Can I go to the bathroom?
Yes, it's down here. I got presents for you.
You got what?
I got presents.
Is Riley here today? Because I swear.
Here's that.
Yes.
Here you go. She's thick. She ain't got a lot of problems. Can you
Oh my god, it's Thursday. I hate
You
Thursdays.
what? Oh, Thursdays are review days. Thursdays are great.
No, that's why I hate Thursdays.
Can I crumble? Yeah. We're not going to be on purpose.
Thanks. I don't want to do it. I'm
Well, I mean,
the process goes tomorrow.
Need food?
I dropped it on the floor and crashed, so let's go.
Go food.
Yeah. Why don't I would really wish that it wasn't.
Noise.
I know, right?
It's getting better.
It is getting good.
Come to me.
Like,
Oh, it won't. It won't.
Caleb
Not for you,
Carpenter
to me.
was
It won't.
coloring blood through a bunch. Yeah, it's that thing back there, that design over there on the wall, the right
Oh,
side.
send out the fix
Yeah,
it.
we good. Yeah. How you doing, Troy?
Actually broke.
Miss you.
Tyler, unanimous.
Yeah.
Yeah, I know. I
You
just.
doing all right?
There, I guess. So.
I think I
Do the
I think I pulled something in my thigh.
Oh, Mark already gave one.
Yeah.
Sorry, Mark. Who else needs one? Sorry.
Alright, boys.
Take those my birthday. Huh?
All right.
What is it, Mark?
Got him. What'd you do? He just got. All right.
Mr. Mac, I haven't
Go to game
been
club.
card for like 2 days.
Who needs one? Who needs
I
one?
thought game club's on Fridays now.
It is on Fridays now. Can I say it?
I could come to that.
Somebody else?
Fridays.
I don't know how this works.
Don't get out.
Oh.
Just so.